If you remember when we were talking about triangles, we studied, similarity, like theorems on how to prove that two triangles are similar. And one of the conditions that we had to look at was whether or not the sides are proportional. In other words, we had to find a scale factor. Um, the idea of a scale factor can also be used for, similar solids. Now, by definition, two solids are similar if, the ratio of their corresponding linear measures is constant. So, what do we mean by ratio of corresponding linear measures? For example, if you have, let's say, two prisms, the ratios of the length, the width, and the height, they must be proportional. If you have a cylinder, then different cylinders have different lengths or radius or radii. The ratio between any two radii will be the scale factor. Now, why is the scale factor important? Well, because if two similar solids have a scale factor of k, then the ratio of their volumes is just equal to k to the third power, or k cubed. Now, how do we illustrate that? So I have here two cylinders, and one cylinder, cylinder A, has radius 3 centimeters, so cylinder B has radius of 6 centimeters. So let's compare them. We could say cylinder B has a radius that's twice as long as that of cylinder A, or cylinder A has a radius that's half of that of cylinder B. So how are we going to find the volume of cylinder B? Well, if you were given the height, the corresponding height, then we could just actually, find the volume of cylinder B by using the formula. But in this case, we're given the radius of cylinder A and its volume. You can approach this in two ways. Find the actual height here, right? And then maybe use ratio and proportion to figure out the height of cylinder B. Well, let's see. So for cylinder A, the volume is area of the base, which is pi r squared, times the height, which we don't know, right? So the volume is given by 45 pi, and you have here pi, the radius is 3, and then the h is unknown. So this will become 9 pi h is equal to 45 pi. So if we cancel, pi on both sides and divide both sides by 9, then h is equal to 5. So that means the height of cylinder A is 5. So if these two are similar and cylinder B has a radius that's twice as long as that of A, then use the same scale factor to find the actual height of cylinder B. So if you double 5, then this would become 10, so the height is 10. So if we know that the height is 10, so then we can find the volume, which is pi r squared times the height of the cylinder, 10, so we get r squared is 6, so that's 36. So the volume would be equal to 360 pi. So that's the actual volume of cylinder B. But that's just, one possible way of doing it. So let's take another approach. Let me erase all these. And we want to use the concept that I mentioned earlier, that if they are similar, if the two cylinders are similar, then the ratio of their volume is just equal to the cube of the scale factor. So we know that the scale factor is equal to, from B to A, it's 6/3, which is 2, right? So, if we want to find the volume of cylinder B divided by the volume of cylinder A, well, why did I start from B to A and not from A to B? I gotta be consistent with how I ordered them here, right? So I started with the bigger radius than the smaller one, so I'll have to start with the bigger cylinder. So B over A is equal to, according to the formula we read earlier, it's just equal to the cube of the scale factor. What your scale factor is? 2. So that means this is equal to 2 to the third power, which is 8, right? Okay, we know that the volume of cylinder B is unknown, so let's keep the variable there. But the volume of cylinder A is already given, it's 45 pi. So by cross multiplying, or by multiplying 45 pi to 8, we get B is equal to 8 times 45 pi, and that's going to be equal to 8 times 5 is 40, so that's still equal to 360 pi, which is the same as the one we got earlier, right? So both methods work, but this one is, a little bit faster. But if you know how to use both ways, then it's just a matter of which one you prefer.